All right, we're going to prove the hypotenuse leg theorem, which says if we're given two right triangles, so this is specific to right triangles, and they each share a leg, a corresponding leg that's congruent, and their hypotenuse is congruent, their corresponding hypotenuse, which there's only one in each right triangle, right? So if their hypotenuse is congruent and their leg is congruent, and we know that they both have right angles, of course, then they must be congruent, okay? So remember that this is something that we've talked about before that doesn't work, where we have side angle with side angle. And remember, geometry is pure, so usually that doesn't work out, but it does in the case of a right triangle, okay? So 90 degree angles makes it right, makes it happen. So that's the only time when SSA will work, and we don't call it SSA in that case. We call it hypotenuse leg because it's specific to right triangles. Okay, so let's start out with our given. So we're given these two right triangles. So Q and Y are right angles. So angle Q and angle Y are right angles. Okay, and we have that already noted here. All right, and they also tell us that PR is congruent to XZ. So PR and XZ, the hypotenuses. And then we have PQ is congruent with XY. So those are the legs. All right. So let me write in given. All right, so there are a few ways we can go about this proof. If we incorporate the Pythagorean theorem, that might be helpful. But since we haven't really learned that yet, we're going to take a different approach. So what we're going to do is we're going to start with triangle XYZ, and we're going to make a couple auxiliary lines. So we're going to make one from, we're going to extend Y, we're going to extend ZY through Y, okay? And we're going to make a segment YS such that YS is congruent to QR, okay? And that's something that we can do. We haven't learned about constructions yet. That's something that's kind of, when I was in geometry, it was a bigger deal, and we, it's something that kind of more of a staple of geometry class. Nowadays, it's not as widely taught. It's something that we might do, if we have some extra time in the year, which doesn't seem like that'll be the case. But it's kind of one of those things that's pushed off to the side a little bit. But constructions with a compass and a protractor and a straight edge, one thing we can do is make congruent segments. Okay. So what we'll do is we'll extend segment ZY such that YS is congruent to QR. Okay, so basically this segment YS is congruent to this one. Let me put 3. Okay. All right, and you could say construction auxiliary line. Okay, you could say through any 2 points there's one line, because technically if segment ZY, there's 2 points there, so we can extend that line forever and it's still the same line, right? There's only one line that goes through those 2 points. So next we're going to connect the dots from S to X, right? And that's definitely through any 2 points there's one line. So we'll connect, we'll say draw XS, okay? And through any through 2 points, there's exactly one line, right? Okay, so two auxiliary lines here. All right, and so we basically constructed a third triangle here, and now we're going to try to associate XYS with XYZ, and then hopefully use that to associate PQR with the other two as well. Okay, so let's see, what can we say next? We can say that just by looking at the diagram, we can say that XY is congruent to XY, right? And that's by the reflexive property. Okay, and so then I can say, okay, well, this XY in this triangle must be congruent to PQ, right? Because that's a given. PQ is congruent to XY, so I'm going to say, well, and this, maybe this we don't have to necessarily do. I should have put congruent there, to PQ, and that's transitive property. So, you know, these two steps we maybe could have skipped by because this is already explicitly saying that, but we'll just write it just to be very clear, okay? So now we have these two parts, right, congruent in this triangle and this triangle. So we have the two legs congruent, and now let's try to get at this angle here. Okay, so in the picture we can see it's a right angle, but do we really know that it's a right angle? We can't just straight out say that. We have to go through the logical process here. So we know that we have a linear pair, right? So we know that S angle SYX and angle ZYX form a linear pair. Right, by the definition of what a linear pair is. Okay, and then we know that they must be supplementary, right? So SYX and ZYX are supplementary. And that's by the linear pair postulate. Okay. All right, and so what does that mean? Well, that means they add up to 180, right? So measure of SYX plus the measure of angle ZYX equals 180. And that's definition of supplementary, right? So notice how we're going one to the other, right? Linear pair leads to supplementary. Supplementary leads to add to 180. Okay. All right. So we know that angle Y is a right angle, right? So angle ZYX, that's a right angle. Okay. So we can say measure of SYX plus 90 equals 180. So we basically did some substitution there. Okay, so I'm going to put substitution. Oops. All right, and then now we can use subtraction to get this over here, right? Subtract 90 from both sides. So if we subtract 90 from both sides, we get measure of SYX equals 90 by subtraction property of equality. All right, so let's keep going. So we have 11. So now that means that angle SYX is a right angle and that's by definition of right angles. Okay. And so now we must know, okay, well, SYX must be congruent to angle Q and angle Y, right? Angle ZYX and angle Q. So angle SYX must be congruent to angle Q and it must be congruent to angle ZYX. And that's by, we know that all right angles are congruent. All right, so now we know this angle is congruent with this angle and is congruent with this angle. So now we have enough to say side angle side, right? Side angle side. So we have enough to say that, okay, well, triangle XYS must be congruent to triangle PQR. Triangle XYS must be congruent to triangle PQR. Make sure I got the letters in there right. X corresponds with P, Y, Q, S, R. Okay, and we can say that by SAS, side angle side. Okay, so then we can say, okay, well, these two triangles actually, let me not relate those just yet. So let me say, okay, well, if these two triangles are congruent, that means that all their parts are congruent, right? So I can say, okay, well, this is congruent with this. And the reason I want to do that is because I know that these relate, right? So if I can get these to relate, that'll help me relate this to this, this to this, and then we can go from there, okay? So I'm going to say that XS is congruent to PR by CPCTC. So XS is congruent to PR. And that's because of corresponding parts of congruent triangles are congruent. Okay, and if XS is congruent to PR, I already know that XZ is congruent to PR, right? So that means that XS must be congruent to XZ. And I know that by the transitive property of congruence. Okay, so basically I'm just saying that this is congruent with this. And now I have enough to say that this is an isosceles triangle, right? So this triangle here, the triangle that's formed by the two joined triangles. So if it's an isosceles triangle, I can say, hey, this angle is congruent to this angle, right? So I can say angle Z is congruent to angle S. So angle Z is congruent to angle S. And that's the isosceles triangle theorem. Okay. And now that that's true, now I have enough to say angle, side with angle, side, right? All right, so now I can say that triangle XYZ is congruent to triangle XYS. Triangle XYZ is congruent to triangle XYS by angle, side. And then now that those two triangles are congruent, so now that I see that this triangle is congruent to two different triangles, that means those two triangles must be congruent to one another, right? By the transitive property of congruence. So I can say, okay, triangle, I should have made this a triangle here. Triangle PQR is congruent to triangle XYZ by the transitive property of congruence. And there we go. So that's how to prove the hypotenuse leg theorem. There's different ways to do it. The book does a little bit different, kind of a short informal paragraph proof. This slide that I actually had here did it a little bit differently than the way I ended up doing it as I went through. So maybe you can find a more efficient way to do it than that. But anyway, we proved the two triangles are congruent, and thus we proved that hypotenuse leg theorem is true.